Hello, my name is Mr. IK, and my goal is to raise your confidence in math. In this video, I want to teach you how SOHCAHTOA works. You've heard this acronym so many times, SOHCAHTOA, and it's usually used when you're dealing with right triangles. And here on my screen, I have an example of a right triangle. A right triangle is any triangle that has a 90-degree symbol. And obviously the 90-degree symbols are usually represented with this block shape right here in the corner. Okay, so whenever you see a triangle that has this squarish shape here, it means that it's a right triangle. So how do you apply SOHCAHTOA to a right triangle? Well, to begin, we need to understand what SOHCAHTOA is really about. The SO that you're seeing, which is the SOH, actually is S equals O over H. And then the CA, which is CAH, is actually C equals A over H. Okay, and then the TOA, which is TOA, is actually T equals O over A. So what do these letters stand for? Okay, first let's start with the S, right? If you come down here on the right corner here, you will see that the S stands for sine, okay? And it's usually related to an angle. Okay, so the S stands for the sine of an angle. Now the C, which is right here, stands for the cosine of an angle. And then the T, which is the bottom one here, stands for the tangent of an angle. As you can see, I separated these things because I want you to know that the S, the C, and the T, whenever you hear sine, cosine, or tangent, it's usually speaking about how it is related to a specific angle. Okay, and we'll talk about that in a little bit here. And then let's move over to the sides, right? On this first one here, you see O over H. So what that actually is just saying is opposite over hypotenuse, right? O stands for opposite, and the H stands for hypotenuse. And then on this second one, you see A over H. It actually is just saying adjacent over hypotenuse. Again, these are sides, right? We'll talk about this again when we get back to this triangle here. That's what I'm going to use to really explain it a little bit more. Okay, so the A over H means the adjacent side over the hypotenuse side. Okay, adjacent side over hypotenuse side. And then the last one here, you have O over A. So that's just saying the opposite side over the adjacent side. Okay, so when you look at a triangle, notice how many sides does this triangle have? A triangle has 3 sides. Okay, that's why we have 3 of these words here. So that means that one of the sides of this triangle is going to be the opposite, one of the side is going to be the adjacent, okay, and another side is going to be the hypotenuse. Okay, that's how this works. One of each side is going to have to be 1 thin. Okay, that's why you have the 3 words. Okay, now let's now talk about how to know which one is which. Okay, if you look carefully at a right triangle, you will notice that every right triangle has an L shape. Here is the L shape highlighted in red. Every right triangle must have this perfect L shape. And in the middle of this perfect L shape, you will always see the 90-degree symbol, right? The blockish symbol here. That means 90 degrees. So whenever you have a right triangle, the first thing you should always do is identify the L shape. Once you've identified the L shape, then you need to remember this. The opposite and the adjacent So the opposite side and the adjacent side always live on the L. Okay, so the opposite and the adjacent always live on the L. It's a rule. They can't live anywhere else. So you see how this L shape has two sides? One of them will always be the opposite and the other will always be the adjacent. That's just the way it is. One of them will always be the opposite. One of them will always be the adjacent. Okay, remember I didn't say the hypotenuse yet. Okay, the hypotenuse does not live on the L shape, does not live on the L shape. Okay, so one of them is the opposite, one of them is the adjacent. So then you might be asking, well, how do you know then which one is the opposite and which one is the adjacent? Well, that's where the angle comes in. Okay, so this symbol that you're seeing here is called theta, and it just means an angle. So this could be 10 degrees, 20 degrees, 30 degrees, whatever angle that you're given in the problem that you're working with. Okay, this angle tells us which side of the L is the opposite and which side is the adjacent. Okay, so the best way to do it is to always look for the side that is opposite first. Always find the opposite first. How do you find the side that is the opposite? So if this is my angle, right here that I'm focusing on, okay? If this is my angle that I'm focusing on, ask yourself, which side is directly across from the angle? Well, if you were to draw an arrow from this angle, you would notice that it points directly to the 1. In other words, the side that I've labeled 1 is directly across from my angle. So guess what that means? It means that my 1 is the opposite in this specific example. The 1 is the opposite because it's directly across the angle that we're looking at. Okay, so what does that make 2? What does that make the side label 2? Well, if the side that is across from the angle is the opposite, then that means the other part of the L, right? The other part of the L has to be the adjacent, right? Because remember what I said, the opposite and the adjacent live on the L. If one of them is the opposite, then the other is definitely the adjacent. So in this specific example, 1 is the opposite and 2 is the adjacent. Okay, so what does that leave us with now? That leaves us with the hypotenuse, right? That leaves us with the hypotenuse because we've identified the first two, the opposite and the adjacent. That leaves us with the hypotenuse. The easiest way to identify the hypotenuse is that it's always across the 90-degree sine, right? The block sine. Okay, so that means that 3 is our hypotenuse. Okay, so if you think about it, if the opposite and the adjacent live on the L, right? The only side, if the opposite and the adjacent live on the L, the only side remaining really is this side here, right? So as you can see, the side that I have in green is my hypotenuse because it is definitely not on the L, right? It is definitely not on the L. It is the side that connects the ends of my L, right? It connects the ends of my L. Another way to see it is that it's across from the box, right? It's across the 90-degree box here. That's another way to know the hypotenuse. Okay, so 3 is the side label 3 is my hypotenuse. And again, these are just random labels that I put on here. Okay, 1, 2, 3, they're just random. Okay, but I just wanted to use it to help us understand how to identify the sides. Okay, again, I always first identify the opposite because it's easiest, it's the most important one to find first. Okay, so that to avoid confusion, find the side that is directly across from the angle that you are working with, okay, the angle that you're given. the side that is directly across from it is the opposite, and the opposite also lives on the L, right? The opposite lives on the L. So once you find your opposite, then the other side of your L is your adjacent, okay? And then the third side, which connects the ends of your L, okay? The third side which connects the ends of your L, or another way to know it is the side that is across from the 90 degrees, that's your hypotenuse, okay? So that's how you identify your sides. Okay, I've intentionally moved our triangle around here, and I put some different letters and I put the angle in a different position, and I want to see, can you identify which side is your opposite, which side is your adjacent, and which side is your hypotenuse? Well, using what we've just learned, can you figure it out? You can pause the video at this point and see if you can figure it out. And then once you do it, play the video and see if you got it right. Okay, so let's see, using what we just learned, where is the angle located? The angle is located right here in brown at the very top here. So if the angle is right here in brown, then I know that the side that is across, directly across from my angle, is going to be my opposite. Okay, and also my opposite lives on the L. Here is the L in red, right? Remember, the L is always going to be a perfect looking L. Well, this one is like a backwards L, but it's still the L shape. And you can see the 90-degree symbol and like in between it right here. Okay, so the opposite is directly across. It's directly across from the angle that you're working with. Okay, so that means that this side is actually now my opposite. Okay, so the opposite depends on where the angle is located. The opposite depends on where the angle is situated in your triangle. If it's up here, then notice that the opposite is now down here. Okay, notice that. Okay, so if the side labeled G is my opposite, then that means that the other side of my L is going to be my adjacent. Okay, so the adjacent is always going to be the other side of the L. That is not your opposite, right? So after you find your opposite, then the other side of the L is your adjacent. Then after you found that, then your hypotenuse is pretty easy to find, right? Because your hypotenuse is always going to be the side that connects the ends of your, it connects the ends of your L, okay? Connects the ends of your L. And it's also across the 90-degree symbol, right? It's always across the 90-degree symbol. So the side labeled H is our hypotenuse. Okay. So now, going back to this first example, we've learned how to now identify the sides that are the opposite, adjacent, or hypotenuse, right? So we did this part, the sides that are the opposite, the adjacent, or the hypotenuse. Now we got to figure out how to then do the sine, cosine, and tangent. So if you're asked to find the sine, you go right here to the SO, right? Because S stands for sine, right? And we know that the S, which is sine, equals the opposite side over the hypotenuse side. Okay, so let's use that information to set up an equation. So if I'm ever asked to find the sine of an angle, now notice how for sine, I only used SIN instead of the full SINE. Okay, it's just an abbreviation thing that people do in the math world, okay? So instead of SINE, you see SIN. It's just the same thing, okay? So if you're asked to find the sine of an angle, all you have to do is follow this pattern here, right? Follow this setup here. You have to find the opposite side over the hypotenuse side of that angle, okay? Of that angle. So the angle is right here. The opposite side of the angle is 1. We've just learned how to find the opposite, right? And then the hypotenuse is 3, right? We also learned how to find the hypotenuse. The opposite is 1 and the hypotenuse is 3. Okay, so the sine of this angle is the opposite, which is 1 over the hypotenuse, which is 3. Okay, so the sine is opposite over hypotenuse. Let's move over to cosine, the ca. Whenever you're asked to find the cosine of an angle, so cosine, as you can see, is shortened to cos. Sometimes people will say cos, right? So that's just cosine. Instead of spelling it like full out cosine, you just say cos. Okay, so whenever you're asked to find the cosine of an angle, you just use your setup again, right? The ca part of SOHCAHTOA, and you go adjacent over hypotenuse, right? Cosine is a over h, adjacent of hypotenuse. So you come to your triangle and you say, okay, what is the adjacent of this angle? What is the adjacent of this angle? Well, we know that the adjacent is going to live on the L, and we know that it's not going to be the opposite, right? It's not going to be the side that is across from the angle. It's the other part of the L. So that means that my adjacent is 2. Okay, my adjacent is the side labeled 2. And then my hypotenuse, we already know how to find the hypotenuse, right? It's the side that is not on the L. So it's going to be 2 over 3. All right, so my cosine of the angle is 2 over 3. And then finally, we will find the tangent of the angle. Again, tan is just a shortened form of tangent, okay? So if you're asked to find the tangent of an angle, you come back to this, and it's TOA, right? Because T stands for tangent. So T equals O over A. So that means tangent equals opposite over adjacent. So that's the TOA part of SOHCAHTOA. Okay, so using that, we're going to know that the tangent of theta is going to have to be the opposite side of the angle, which is 1, right? The opposite side of the angle, which is 1. So that's the O, opposite. So that's the 1 over the adjacent, right? The adjacent part of the angle, which is 2. And that right there is your tangent. So tangent is 1 over 2, right? The side 1 over the side labeled 2. So that's how you find the sine, cosine, and tangent using SOHCAHTOA. You know how to identify the side that is the opposite, the side that is the adjacent, and the side that is the hypotenuse. And you know how to use your SOHCAHTOA to then create your equation. Let's go over to the other example and see really quickly what the sine, cosine, and tangent will be for that second example. So coming over to this second example, we're going to find the sine of the angle, the cosine of the angle, and the tangent of the angle. Before I do anything, I'm going to quickly write my SOHCAHTOA using what we just learned, so that way I remember that I'm actually setting up an equation. Okay, so SOHCAHTOA, and I used the equal sign just so that I remember that this is sine equals opposite over hypotenuse. Okay, cosine equals adjacent over hypotenuse, and tangent equals opposite over adjacent. Now let's use that to figure out these problems. Okay, so the sine of theta is going to be the opposite side of theta over the hypotenuse. Okay, so notice that the opposite of theta is now g. So that's going to be g over, and then the hypotenuse is right here. It's the side that connects the ends of the L, right? The side that is across the 90 degrees. Okay, so that's my hypotenuse. So it's going to be h. So g over h. And then my cosine of theta is going to be the part of it, right? So that's going to be adjacent over hypotenuse, right? Adjacent of hypotenuse. So my adjacent is the other part of the L, the side that is not the opposite, okay? The other part of the L. So that's going to be F, okay? So it's going to be F over the hypotenuse, right? Which is my H here. The hypotenuse. We just found not too long ago that the hypotenuse is H. Finally, we're going to find the tangent of the angle. And what do we know about the tangent of the angle? The tangent is the opposite over the adjacent. Okay, the opposite over the adjacent. So here is my angle. The opposite is G, right? The opposite lives on the L. And then the adjacent is the other part of the L that is not the opposite. Okay, so that gives us G over F. Okay, so G is the opposite and F is the adjacent. Well, ladies and gentlemen, I hope this really helps you from now on know how to apply your SOHCAHTOA and know how to set up an equation. Okay, and again, I already have a video on how to then use the equation that you set up to solve for a missing part of a triangle. You can check that out as well after this. If you enjoyed this video, if you found it helpful, I want to invite you to go ahead and hit the like button so that way more people can see this video, and also subscribe to this channel if you haven't already so that I can continue to make more videos. All right, thank you and have a good rest of your day.